Hey, welcome to the Busy Plugin Developers webinar, the third episode marked with the number 2. Today we have invited Łukasz from Virtus Lab. Łukasz will give us an introduction to the ide-probe, a framework for testing plugins for IntelliJ-based IDEs. But before that will happen, Anna Maltseva, our marketing specialist in the JetBrains Marketplace team, will talk about the most crucial part of the plugin development from marketing perspective. All right, Anya, the stage is yours.
Yeah, thanks. And if you have questions during the presentation, please write them in chat. Jakob will try to answer them. So hi, everyone. I'm Anna. And as being said, I'm going to provide you 5 tips for optimizing your plugin page on JetBrains Marketplace. But first, why do you even need to optimize your plugin page? If you're developing a plugin for, let's say, some language or framework, let's take Scala, for example, would it be enough to say just support Scala language on your plugin page? I would say no, and here is why. So JetBrains Marketplace is an ecosystem of more than 6,000 plugins, and there are many awesome plugins out there, really, but some authors just underestimate the content of their plugin page. But however, it can be a very effective marketing tool if you use it properly, of course. So when you publish your plugin on the marketplace, it becomes available to 10 million JetBrains product users. But how users generally find your plugins on the marketplace? So they can go to, if they use JetBrains IDs, they can go right there and find plugins they're interested in on in IDE Plugin Manager. And also, they can find it right on the marketplace site. For example, they can just browse it there, or they can enter some search query in search engines, for example, Google, and land on your plugin page. And let me give you some numbers. So as you've seen on the previous slide, monthly around 700,000 users visit JetBrains Marketplace site. And half of them come from organic search. So it's a really important source. Yeah, it's and yeah, a big traffic comes from search engines, and of course you should optimize your page. But when people land to your plugin page, what do they normally see? There is a structure available to every marketplace author, and there you can usually find some general information about plugin, its description, some media like video and screenshots. Also an author can provide their general usage instructions, see the rating, and add some links, for example, to Backtracker, support, or your site. So let's come to the question, what an author should write there to make a plugin standing out. And so let's get into the detail with my tips. The first tip is creating a compelling plugin description for your plugin. You should do that before uploading a plugin to Marketplace, because the plugin page takes the description from a plugin.xml file, as you probably know. And you will be able to change the description only by resubmitting a plugin. So you should think in advance about the content of the page. And my first tip would be making it easy to read and not overwhelming with details, because your prospects are busy and they're not willing to spend much time reading a listing. So make sure your description is concise and offers a clear value proposition. So, and I suggest to start the content of your page by answering to the following questions and defining your product's value proposition. So you should answer such questions as what needs does it address and who will benefit from it the most. We can see an example of value propositions. For example, a not good enough value proposition would be add support for Rust language, and better one would be brings JetBrains quality language support and the full IDE experience to your Rust workflow. Then I offer to write you some benefits and not describing the features. Because before describing what you're selling, you should tell prospects how your plugin can solve their challenges and what differentiates them from competition. And of course, to whom the solution is targeted. So, for example, for benefits, simply for benefits, if you're offering, for example, a language plugin, describe how your product helps your customer accomplish tasks faster, stay productive, write more reliable code, and so on, instead of just listing some features like smart editing, refactoring, code generation, and so on. And my next tip about description, like it's more of a life hack. Sorry for me messing up the slides. It's adding inline links to the description. The thing is that if you want that users find your plugin just from the plugin manager, you need to add some links just to description, because it will be displayed in the plugin manager interface. Here we see the example of Bash Support Pro plugin, who did edit those links, so you can go and see some additional info right from the IDE. And going to the next tip is creating general usage instructions. So the thing is that what might be simple for some users might not be simple for others. So as being said, some users come to your plugin page from search engines and are not familiar with JetBrains IDE. And and we have a special section there where you can write usage instructions. I've noticed that this feature is not widely used by plugin authors, and yeah, this is probably because it is not shown in the IDE plugin manager that I showed on the previous slide. But yeah, you should really think of users who find your plugin via search engines. They will lack information about how to install plugin and how to use it together with JetBrains IDEs. My next tip is about SEO. You should really take it into account because again, because of the search engines, you should draft your description with with SEO keywords in mind. But of course, there is a general tip to avoid keyword stuffing and using uncommon abbreviations. The thing is that the first line of your description that goes to a plugin page also appears can also appear in search. So ensure you mention keywords relevant to your listing in your tagline. Here we have some examples for how, for example, Rust and Scala plugins look in search. We can notice that the description Rust language support, which is written for Rust plugin, is is not very effective, let's say, because it doesn't contain much information, and people who find it on search engine may not convert. And for Scala plugin, it takes information from general usage instructions. So Google considers this information more relevant for me as a user when I search Scala IntelliJ plugin on search engine. So it's just to give you an idea that SEO aspects are also important when writing plugin description. Because the users of your plugin are not only those who use IntelliJ-based IDEs, but also those who just search for some solution on the internet. Yeah. And of course, optimizing your listing for SEO will help you show up higher in search results, which is of course important for you. But yeah, how to determine the best converting keywords? You can head to Google itself and make a list of search terms and test them to see what show up on search. And here I also can recommend Google Keyword Planner or using some special SEO tools like SEMrush. It has a free plan, so you can try it and use it and see the volume for specific keywords. So to make an idea, what should you write there? Going to the next slide. Yeah, the tip number 4 is adding visuals. The thing is that users are more likely to interact with listings that have visuals. And recently we added a new feature to Marketplace, like adding YouTube videos to your page. Though it's not mandatory to add a video to your page, it would be a very effective tool to showcase your solution. It is a good idea to include a short video, for example, with some call to action at the end to inspire your viewers to take next steps. For example, if you're offering a paid plugin on the marketplace, you can you can offer a free trial as a call to action. And my next tip is using custom pages. We also have this feature on the marketplace because you don't want to write everything. So of course, you can have a lot of content, but writing everything on the main overview page is not a good idea. As being said, your prospects are busy and they're not willing to read everything, like documentation and big installation instructions from your overview page. So you can add some other content right to the marketplace. For example, you don't have to create your site if you don't want to, like if you're a small plugin developer. But you can still add some information such as announcements, list of features, change log, or even corporate blog. Here I have an excellent example of our plugin developers, GPA Buddy, who have a corporate blog right on their marketplace page. Yeah, so my tip is be creative and use the possibilities of a marketplace that we provide to add description to your page. And yeah, that's all from my side. I just want to wrap up. So optimizing your plugin listing can help you your customers make more informed choices. And if you do that, you can grow your conversion rate and of course the install base. So and the tips for optimizing your plugin page are maybe simple but worth mentioning. So you should optimize your content for your plugin page, especially the plugin description. Keep SEO keywords in mind, and add some visuals, and use custom pages to provide more information about your plugin. And yeah, now that's it from my side, and I want to give a word to Łukasz, who will continue with the technical part and describe ide-probe, a framework for testing plugins. Thanks.
Hello everyone. I'll show you today a brief introduction to ide-probe. So let's just jump into it. What is ide-probe and what is this used for? So ide-probe is a framework for testing how plugins work in integration with IDE and other tools, and this framework is written in Scala. We're currently using it for a couple of things. The first thing is the integration testing of IntelliJ with Pants, Scala plugin, Bazel, Thrift, and FastPass. So FastPass is a tool, command line tool that translates Pants to BSP. So basically, it's testing integration of IntelliJ with 4 different plugins. We can, in this environment, import the project and test if it looks correctly and everything works. And these tests are open source, so you can access them, read them, run them. They run on GitHub Actions, so it's also reproducible. We also have internal fork of this repo that just changes the config, and it starts testing on different projects on our internal monorepo to see if in that environment everything works, because in open source we just test on very small example projects and IDE can behave differently. Another thing we do is performance testing of scenarios that users do every day. For example, project import time or incremental compile time. So to describe this a bit, this scenario looks like we open a project, we build it, and then we add a print line and compile the project again and measure how long it took, and then add another print line, compile it again. We measure like it multiple times, and we can see how long it takes for the users to compile a small change. Then we store these results, and we can analyze if they are regressing for some reason, or we can verify if IntelliJ update or some plugin update can make it better or worse. So this is a tool for monitoring this. Next usage is testing of Git Machete IntelliJ plugin. It's a plugin for a tool also created at our company that helps working with Git branches, and it has an IntelliJ plugin. It has tests. It's written in Gradle, so it's also a good resource to look at how to set it up. Another one is we're working on testing another monorepo integration of IntelliJ that works on Windows, but this is currently a work in progress and likely a closed source. We also are building external API test jar. So if you want to run tests of IntelliJ, the regular test, you need an API, a jar with the API for these tests. And somehow this jar is not published anywhere, so we can build it from sources. So to have a reproducible build, we just on CI start ide-probe that starts IntelliJ with IntelliJ community sources, builds this jar and uploads it to GitHub releases. So we can mostly automatize any tasks on CI that are related to IntelliJ. And last up, we have like a long list of projects or sub-projects in the monorepo. And for each of them, we can periodically check if import, build, and test of this project works correctly from the IDE. This helps us to monitor if everything works correctly, because we are migrating to a different build tool. We want to check if everything works correctly from IDE in this build tool. Okay, and why we created ide-probe? So at the time, like about a year ago, when we started working on it, existing ways of testing IntelliJ were not ideal. They were like calling internal APIs directly. They were running in test mode and in headless mode, and IntelliJ behaves differently in that way. There is a different control flow, different threading, and it did not reflect what users could see or could not detect UI freezes, and we at that time had to deal with many. We fixed already most. So, and our primary need was to make internal IntelliJ releases stable. So we want to be sure that if you take this version of IntelliJ, these plugins, and you run a couple of frequent user scenarios, they all work before we ship the IDE release to our users. So this was our primary goal to use ide-probe with. Okay, let's look briefly how it's work on its architecture, just shortly. So as you can see, for core, it has three modules: API, driver, and plugin. The API is common for driver and plugin. They talk through this module, say. So it defines JSON RPC endpoints for commands and queries. And plugin that runs on IntelliJ JVM is just an IntelliJ plugin that starts a server which implements these endpoints, and it uses public or internal IntelliJ APIs, whatever we need, to implement the behavior of the endpoints. Driver, it runs from your tests in the JVM of your tests, and it is a client, and it communicates with the plugin server. So communicates with IntelliJ and sends requests and receives responses. And the driver is also responsible for preparing everything. So installing IntelliJ and plugins and starting it, and then it allows you to communicate with it. And we also have extensions in this architecture. Each extension looks similar to the core, so it also has API, driver, and plugin. And it has custom endpoints. Like if you want to create an extension for your plugin, let's say for a Scala plugin, you would need to create a Scala extension, and then in your plugin, you depend on Scala plugin and you can call its APIs. So this is how it works in short. And let's look what can it do currently. So first, I'll show you the endpoints that we have so far. We can build project in any scope you configure, build an artifact, you can kill the IDE, you can refresh file system, you can invoke any actions, you can list what plugins are installed, you can list background tasks, you can open project, close it, list what's open, query the metadata about the project. You can change some settings. You can change the trusted path. This helps you with this prompt that asks you if you want to trust the project. By default, ide-probe just disables it. You can open an editor with some file. You can navigate within this editor to different places. You can check what editors are open. You can check references from file. You can check what freezes occurred so far with duration and stack trace. You can report them. You can check logs, especially look into errors. You can run different things, applications, JUnit tests. You can run tests from context, from different scopes. You can rerun failed test. You can wait for notification, take a screenshot, run a local inspection, find a class. And we also have 4 extensions so far. We have extension for Scala plugin. They don't have many features, but what we needed, so we can enable SBT shell, because some projects don't import, some SBT projects don't import through regular interface. You can import BSP project, we can run Scala tests specifically. And we have some also features for pants extension and bezel extension. We have a robot extension that integrates with JetBrains Remote Robot. I will talk about this a bit later. But ide-probe can set up JetBrains Robot for you. So it can download it, install the plugin, configure the right port, and connect with it and give you the access to Robot API. Okay. Next thing ide-probe can do is installing and starting IntelliJ. So you can specify custom places where you want IntelliJ to be found at. So if you have a CI that does not have access to external internet, you can change the resolvers. Also, all of the resources that are downloaded or built are cached, so you don't have to download IntelliJ on each test. And we can install plugins in 4 ways. First is from URI, so it can be just a link to a file in the internet or a file on a local machine, or you can provide IDE version and optionally channel, and this will use resolvers. By default, it will download the plugin from JetBrains Marketplace. You can use bundled plugins, so plugin from your resources. This is mostly used internally for the probe plugins, but yeah, it's also possible. And the last step is from sources. So you can write a custom builder that reads a config, and based on it, it can build your plugin. So for example, we have it implemented for Scala plugin and for Pants plugin. This means you can give a Git URL, a commit, or a branch, whatever you want. And ide-probe will run the builder, which will clone this, build it, and cache it, and then can install it. And this also can work on CI, so you don't need a release of a plugin to test if it works using ide-probe. And during startup of IntelliJ, you can configure environment variables that are used, VM options. You can enable headless mode if you want, but by default we use UI mode, as it shows more true to how IntelliJ works. Another thing is workspace setup and cleanup. So each test happens within some workspace. So apart from installing IntelliJ, there is a workspace that you are testing on. Usually, it contains the project that you want to open in IntelliJ. And you can set up this workspace from template. So it means it's copied from some place, and in your test, you see the copy of this, and you can do all sorts of things, and it will be cleaned up after. You can copy it from a directory that's in files, but also it can be in resources, also in jar, or from Git. So you can clone a repo for the tests and then just delete it. And we have an option to use an existing directory without cleanup. So if you have, for example, a large repo that's cloned already, you don't want to clone 20 gigabytes on each test, then you can use the existing repo and do a custom cleanup if needed. Okay, next feature of ide-probe is advanced wait logic. Frequently, you need to do some additional waiting when you're interacting with IDE. For example, when you invoke some action, it might trigger some background tasks, or when you are opening project, the actual call to open project returns quite early, but then there is a syncing, it runs a build tool, extracts the structure, and then there is indexing, so you need to wait quite long until your project is actually imported fully and you can interact with IDE in all of the ways you might want. And there is this wait logic API that helps you form different conditions on waiting. So I have on this slide 2 examples. The first one is the simpler one. It waits for a background task to complete, and the string that it's looking for, the substring in the task, is indexing. So it waits it waits till task with indexing name appears, and when it appears, it waits till it completes. So these tasks, this wait logic makes sure that indexing was started and completed. And there are multiple optional arguments here. For example, max wait before task. This will make it wait for at most 5 minutes until it sees indexing. If it doesn't see indexing in this time, it's considered an error. So something wrong happened in the test. Let's look at another example here. This is called empty named background tasks. It means this wait logic will wait until background task list is empty, but will only look at named background tasks. So tasks that have name and are shown in the UI, because there are many tasks that pop up in this list of background tasks that are not really relevant. So this is actually the default waiting in ide-probe after most action, but you can always override the wait logic to different one if you want. And at most it waits 20 minutes, so there is a timeout on waiting. And as we will be waiting for 20 minutes, we can do something in the meantime. And we have this do while waiting, where you can pass a code block that will be executed by default every 5 seconds during this waiting time. And in this example, I'm closing tip of the day to get the IDE window clean. And it's wrapped in do only once, because when we close the tip of the day once, we don't need to repeat it again. So I use this utility class. And we also check for build panel errors. So while importing, while we're waiting for the background task to finish, in the meantime, we can detect that in the build panel, there is some error and the import would actually fail. So we can report this error and throw from here an exception that something is wrong with the import. This is using Remote Robot, by the way, and these two methods in this example. So you can do, there is a lot of methods to wait for different things and a way to construct your own. And this waiting logic is quite advanced. It will not miss, sometimes one task finishes and shortly after another starts, and it will not fall into this trap, and it will wait till everything completes. Okay, next thing we have assertions and benchmarking. So we can optionally fail in case errors happen, and in case of freezes. So if you want to assert that no freeze can happen in your test and errors, you can have this. Another feature is duration assertions. So you can assert that project imports, for example, take less than 10 minutes, because if it takes 20, it means something wrong happened. So in your plugin, you did some mistake and performance is much worse for the import, or something changed in recent IntelliJ version and you need to report it. Also, there is a simple benchmarking framework added to ide-probe recently, and it supports measuring any code, but it conveniently integrates with even complex ide-probe scenarios. So this is why another small benchmark framework was created instead of using existing one. Okay, we have a rich reusable configuration. We're using Håkon. This is human optimized config object notation. So it's a superset of JSON and Java properties, and it is used for configuring everything in ide-probe. And also some specific configs for test cases can be put there as well. But you don't have to use config files. You can config everything from code as well if you want. But I think it's more convenient from these files. And it's type safe thanks to pure config, so it can map your config values to case classes or any types actually. So in this example here, you see we take a runner from config using get because it's an optional, so we expect it or not. and we can take modules for test, list of modules for test like this, and we can use it from our test. So here's an example of, let's imagine a base configuration file for your tests. Let's call it ide-probe conf. And inside the probe key, we put all the settings related to ide-probe. So under IntelliJ version, you can specify the version, the build, and the release version. Release is not mandatory. And it will download this version of IntelliJ for you. And you can specify a list of plugins. Here I just have one plugin, Scala plugin in this version from Channel Nightly. And ide-probe will download and install it for me during the test. Also, I can configure a path where screenshots are going. This is a feature of Håkon that I can embed an environment variable here and with a question mark. So if the variable is not here, it will just be ignored. So I can optionally override ide-probe screenshots their path from on CI, for example, and locally I can have it in default directory. So this is quite advanced config language. And next up, we have library management conf. It's named after the project that we are running a test on. And here we include ide-probe conf. So we take all of the settings that are there already and add new settings. Here we are configuring probe. So we say workspace.path equals GitHub SBT library management. So when running IntelliJ fixture, ide-probe will clone this repo first and give us this directory available as workspace. And below this key, you see it's outside of the probe. So it means these are custom settings that you can add. You can add anything here and read it in your tests, like here. Okay. Other things that we have, debugging. So you can easily debug your tests without a problem just by starting a debugger with your test. But if you want to debug the IntelliJ that is started by ide-probe, you can just set ide-probe debug equals true as an env when starting tests, and it will start IDE in remote debug mode, and you can attach to it. You can change the port or make it suspend if you need. We support UI tests on CI out of the box through XVFB. And this is X virtual frame buffer, and it supports running window environment on CI. So you only need to install XVFB on your CI in Docker, for example, and set environment variable ide-probe display to XVFB. By default, it uses native and it just opens the window on your screen. ide-probe is easy to integrate with different test frameworks because it's basically just a class that you can create, and it allows you to run IDE and clean up after it. There is available integration for JUnit 4, and it supports running one IntelliJ instance for all suite of tests. So you can start IntelliJ once and run multiple tests against it, or you can run it each time for each test case. It depends on your use case. And it supports multiple IntelliJ runs in the same workspace in one test. So you can start IntelliJ, close it, start it again in the same workspace. And we also have some utils. So if you are calling some shell APIs or interacting with files, there are some utility functions or some reasonable API to do this. Okay, and now how it relates to Remote Robot, which is an existing library by JetBrains for testing IntelliJ. So it mitigates all of the initial issues we had when we decided to create ide-probe. But ide-probe can now do more things, so we'll still keep it and use it. And we integrated Remote Robot with ide-probe as an extension, as I mentioned earlier. So This allows us to conveniently interact with UI without hacks, because Remote Robot allows us to click on certain buttons, and from inside IntelliJ API, it's not that easy. So it depends on the scenario. Sometimes it's easier to use Remote Robot. Sometimes you can use our API. So ide-probe adds this setup, installing IntelliJ, preparing everything, workspace, waiting, and things like that. And Remote Robot is good for interacting with IDE, but it's sometimes more stable to call the API from the inside of IDE than to click some buttons. So it sometimes can be flaky. But on the other side, it is much easier to add some method call or something to Remote Robot, because you just put it in JavaScript string. In ide-probe, you code in Scala or Java, but you have to set up a plugin. So preparing your custom endpoint for ide-probe is harder than just call it through Remote Robot, but using ide-probe approach, it's more maintainable, so because you're not writing in JavaScript strings. Okay, I have here, for example, usages. The first one is in Git Machete IntelliJ plugin. It is a UI test suite, so you can look there how it's done. This repo actually uses ide-probe just to set up everything, but for interacting with IDE, it uses Remote Robot mostly. So this is how it's done here. And IntelliJ pumps plugin test, this is what I'm about to show you in a minute on a demo. And this one, we also have some examples in the Virtus Lab /ide-probe. So in the ide-probe repo, there are some examples that you can look at. And if you want to know how to use ide-probe, just open it on GitHub, and it has quite extensive, not complete, but quite extensive documentation in the README file in ide-probe. And feel free to add issues if something is unclear. So I'll now try to show you how ide-probe is working, just really briefly. So this is the IntelliJ Pants plugin tests repo. And here's run up test. So this test will run an application and test that it works correctly. It has two variants, running with Pants build tool and with BSP, and they only differ in the way the project is open and the way the project is built, because in Pants plugin, for example, you need to run custom action to build everything. And aside from that, the test code is the same. So let me start it, because it can take a while, and in the meantime, I will show you how it works. So as you can see, it's already installing IntelliJ, because I have it downloaded and cached. If it wasn't installed, it would also show fetching. So it just needs to unzip it to a custom directory and then install all of the plugins. So you can see there are many plugins to install here. And now it's starting IntelliJ. It should take me to another desktop with where IntelliJ should show in a minute. Yeah. And now it's generating a project in background, and we'll open it in a second. Yeah, project is loading. So maybe let's go to the logs for a while. Here are like stack traces from Remote Robot, actually from Netty. But then you can see our robot is available here. You can go to this URL and see the robot. Queries for the open project. So you see all of the endpoints that are executed. It shows also that welcome frame was opened and closed. And you also see all of the logs from IntelliJ. You see that tip of the day was closed, and now we are waiting for one background task, updating indexes. So you see here a list of background tasks we are waiting for. And the project is imported basically, but it's still indexing. So once it completes indexing, it will build the project and run the app. So while this is happening, I can show you how it works. We first create a fixture from config. This is a method from ide-probe fixture that we inherit from. If you don't pass arguments here, because the argument here is the config, if you don't pass arguments, it will infer the config from the test name. So it will look for run-app-test.conf file. It's for the config. I can show you. This is the resources, the config file for this test. So let's maybe, here you can see it's already running the build, and in a second it will run the app. But Pun's build are quite slow, so maybe we'll just see it in the logs. See, now it invoked an action, compile all targets action, and now it's waiting for at least 10 minutes, at most 10 minutes, for a compile message notification. This is how we prepare the integration with building tests, with building in Puns. Okay, so it reads this config file here and runs IntelliJ. This gives you a running IntelliJ fixture. We open project, we build the project using this extracted code here, and then we read from config the application run configuration. So it contains the class name and the module name that we want to run the app from. And we also read all the expected data from running the app. So we want to know what's expected exit code, expected standard output and error. Here we expect exit code 0, so a success, and thrift struct and with a new line. This is what we expect. You don't have to put it in config, but we use this test for testing 2 repos. So then we can just change the config without touching test. And here we're just testing because the result gives us the stdr, the std output, and the result. Okay, the test completed. Running app was very fast. But you can see it sent a run application with class main in this module, and the response was as expected with exit code 0. Yeah, the IDE closed, it's shutting down, it's now closing the thread pools, and the test completed successfully. So I'll just show you how config is organized here, and it will be all. Because this is just specific to this test, and then we include this thrift example ide-probe conf. So we have 3 example projects in this repo. This repo is quite big and complex. This is why there's quite a lot of indirection here and multiple config files to reuse everything. So this file defines that we take this thrift example directory from projects directory, and we take it from class path, so from resources. And here's a custom key that Puns extension understands to know which project to import. And we further include the base conf. The base conf is used for all projects, and it contains custom VM options that we use for IntelliJ in our internal distribution. Here we have the version of IntelliJ, the version of plugins. Oh, I see it's black for some reason. Sure, why? Maybe we can, like, I don't know, restart the screen sharing. But Actually, I was almost done. So we can inherit these config files, and we can structure our config in like reusable way and change it easily. But I think I managed to show you that ide-probe started the test and ran it correctly and ran through multiple endpoints. So I think that would be all for the presentation, and I can answer some questions.
Okay, thank you very much, Łukasz, for your presentation. Thanks, Anna. And let's check now if we have any questions appeared in Slack. I mean chat. Yep, the one is it just black for me? Yeah, not only for you, unfortunately. All right. So, in case you will come up with any questions later, you may visit our Slack at pluginsjetbrains.com/Slack, pluginsjetbrains.com/Slack, where we have dedicated channels to Marketplace and IntelliJ platform UI testing, where you may reach Anna and Łukasz and me as well. So, looks like nothing has appeared so far. So, yeah, let's wrap it up then.
Yeah, and yeah, you can find. I will add some links to the video description, so you can just see it on the screen, or I will add it to video description. So later it will be available by the same link, so you can reach out to us anytime. Yeah, thanks.
All right. Thank you very much for watching.
Thanks. Bye.
Thank you.
Bye.